web application security session. Here are the topics that we will be covering. First, a quick review of token-based security. Then we will see how we manage authorization using Node.js and Vue.js. And then hopefully we'll get to these two major topics that are really driving the new modern way of managing web application security is delegated authentication using OpenID Connect. I'll explain what this means. And delegated authorization using OAuth 2. So these are the topics of this session. Just to remind you, these are the aspects of security that us as web developers, we care about. The first thing is authentication, establishing the user identity, typically using a username and password. Once we know the user, we can use some of the user attributes, such as the role of the user, to grant them or deny them some permissions within our application. And this is called authorization. So after authentication comes authorization. Now there is another important aspect of security is confidentiality and data integrity. Confidentiality is some pieces of data that we really care about, such as, let's say, passwords or credit card or private health information, to make sure no unauthorized access, no unauthorized users get access to them. We go ahead and encrypt such information. Now, data integrity is different than confidentiality. Data integrity, you can see the data, but you cannot change it. If you change it, the recipient will detect that there was a change. And this is the example of web security token that we discussed last session. Web security token is a signed JSON message. So I send it to the client can read it, can make sense of it, but they cannot change it. If they change it and send it back to the server, the server will detect that this token has been tampered with. So for preventing tampering or changing data, unwanted change to the data, what we can do is we can sign the message. So there is a difference between encrypting and signature. Okay, so we will address, in this session, we will try to address some of these four major aspects: authentication, authorization, confidentiality using encryption, and data integrity protection using signatures. So let's first start with authentication. So authentication is all about establishing the user identity. There are many ways of doing authentication. The most kind of modern way of doing it, especially in the context of a SPA application or web API-based applications, the modern way of doing it is known as token-based authentication. So the way it works, and for us to really appreciate how it works, let's first see the old way of doing it. So the old way of doing authentication, it is known as session-based authentication. What you do is you ask the user, you give them a login screen, you ask them for username and password. These credentials will be sent to the server side. The server side will check this username and password if they exist in the identity store. And then if they exist, the server side will create a session on the server. So each user on the server side, they will have a session. And a session is nothing but basically an object where we store information about the user. And each session has an identifier. So the server side creates a session for each user, and this identifier of the session is communicated back to the client, using a mechanism called the cookie. It's a small piece of information that gets stored on the browser, and the browser, every time it visits the same website in the future, it will automatically attach the cookie that was communicated from the server. So this is known as session-based authentication. The problem, what is the major problem with this model? The major problem is that it is not scalable. It will not handle large number of users. What's the reason why it's not scalable? Is basically the server is maintaining, for each user, it's maintaining some memory location to store the session detail, the user information and other details about the user. And this is really not scalable at all. Plus, it does not handle, if I want to use multiple web APIs. You know, our application, when we build an application, it might use multiple web APIs. And in such case, these web APIs could be hosted in different servers, and I need to authenticate again to these different servers. And each server I authenticate with, they will have to create their own session. And so it's very bad both for the clients and for the server. The server has to maintain some state and some session, and this makes it not scalable. And the client, if it needs to talk to different servers within the same application, it has to authenticate multiple times. So to solve this, luckily we have this token-based authentication. So this token-based authentication, the way it works, it's super simple and very powerful. You already seen this in the lab. Just to explain it quickly, what we have is we still have the username and password screen for the user to type their username and password, and they log in. On the server side, we check that the user is a valid user. We check against our data store. And then once the authentication is successful, what the server will do, it will take the user object and convert it to a JSON token, JSON Web Token, JWT. So this web token is nothing fancy. It's just a user object in JSON, encoded, and then signed. The server side will sign the token. Why the server side will need to sign the token? Yeah, to prevent the client from changing the token. If the client changes the token and when the server gets the token back, it can detect that the token has been changed. So each time, once I authenticate to the authentication service and I get a token, then whenever I want to talk to an API that is secure API that needs to authorize me, I need to communicate the token. By communicating the token to the web API, the web API can know who I am, what is my role, what I can do, what I cannot do, and it will either authorize me or it will deny access. So I authenticate once, and I can use that token to talk to different web API. So just to show you here how this token looks like, it's really just an object. For example, in here, what I have here is it has some information about me, who I am, what is my role, when I authenticated, what is the expiry of this token. This token might not live forever. You can set an expiry date when the token is issued. Now, all the server does, it takes this user object and it encodes it. So instead of being a JSON object, it becomes a string encoded, and it signs it. It passes it through a signature algorithm to generate a signature, and then it creates a string that has three parts. The first part is just some metadata telling us that, by the way, this is a JWT token or JSON Web Token, and this is the algorithm that was used for signing the token, and this is the actual payload. The payload is made up of claims. Claims is just a security terms that means that these are properties of the user. So each property of the user is a claim that the user is making. So for example, here this token claims that I am an administrator, that my family name is Iradi, that my first name Abdel Karim, and that my email is iradi@job.org. So each of these statements or properties are claims. So that's what a JSON token is. So to show you this concretely, let me just to remind you, I'll do here Postman, just to show you this this process of authenticating and getting a token back from the user. Sorry, from the server. So here is an example. So imagine the user is already created on our database. We know who the user is. So they come in, we give them a login screen, they type in their username, and they type in their password. The username, I think, is called admin, and the password is secret. Then it sends it off to this URL, API, authentication API, and the login URL, and then it sends it off. Once the server will receive it, the server will receive my request. It checked my username and password against the database. It retrieves my user object, and based on the user object, it generated a token. And this token is communicated back to me as a response to my authentication. Yeah. Now, what I do with this token as a client, I store it. Now, for storage, the modern way of storing tokens is by using local storage. So modern browsers, they have like a local database where you can store data using a key and a value. Very simple. All you need to do, you have this built-in object in the browser called local storage, and then here is you can add, this is an object, you can add to it properties. In this case, I am adding a new property called ID token, and I assign it the token that I received from the server side. So basically, I am storing this token that I received, I'm storing it into the local storage. Now, if I want to retrieve it to send it back to the user, to the server, I can retrieve it by using local storage dot the same property name that I used to store, the same property name I will use to retrieve. If the user, let's say, logs out and I need to remove their token, all I need to do is delete local storage dot the name of my token property. So this is basically an object. You know, I can add property because JavaScript is a dynamic language. I can add a property to the object, I can read it, or if I no longer need it, I can remove it. So by doing this, the browser will store the token I received from the server side. It stores it in the local storage on the browser, and I will show you this shortly. Now, once I get this token, if I want to access some area of my website that is secure, some secure web API, such as if I want to get the list of users. So let me try here. I get the list of users. Here it says to me, token expired, because I'm using an old token. You know, the token expires. You as developer, you decide how long the token should survive. So what I do with the tokens that I have, when I call an API, I need to add the token that I received after authentication. I need to add it as a header in my request. So this header is a standard header called authorization. And then what I do here is I put this word bearer, space, and I spaced the token that I received after authentication. So if I remove this authorization and send the request, the server will send me back saying a missing W, a missing token, and I get 403 forbidden. So there are two security relevant HTTP status code that you must be familiar with. There is 401 and there is 403. And you need to know, you need to understand the difference between the two. So 401, when should I return 401? If the user authenticates and the authentication failed, what should I read? Which status code should I return? 401, unauthorized. Although this is badly named, it should be unauthenticated. It doesn't matter. That's how they have, many years ago, they have decided this status. Now, if the user is already authenticated, but they are not authorized to access what they requested, what should we return to them? 403, forbidden. And just to show you this concretely, if I go back to the login, and if I put a wrong password, and I send, you see here what I got? I got 401, the status code is 401 unauthorized, which means the authentication has failed. But if I go to some protected web API and I try to access it without a proper security token, I will get 403 forbidden. You see the difference? 401 if the authentication failed, and 403 if the authorization failed. Okay. Now, if I want this, a call to the web API to be successful, I have to provide a valid token. So let me log in. So the only way to get a valid security token, I have to log in, and the server will give me this token. So what I do here, I can copy this, and when I send a request to the web API, I include this token in the authorization header. And there's a standard way of doing it. You must put this bearer as a keyword, space, and then you paste the token. Once I do this, if I send, everything is successful. The server knows who I am through the token, and it's able to give me what I asked for. Is clear? Because the token has all the information about me, including the role, including my username, not password, my username, other information. And the web API can use those claims that I put in that I have in the token to decide whether to authorize me or deny access. Is clear? This web security token. And there is the web security token is a standard format. I send it to any web API, it will know how to decode it and make sense of it. Now the user is authenticated and they have a token at their hand. Now it's time to protect our web application against unauthorized access. And to do this, we must do it on both sides, the client side and the server side. Yes, the client side and the server side. Now, here, because we are using, on the server side, we are using Node.js, and on the client side, we are using Vue.js. So I'll show you how to do authorization in both. So for Node.js, it's super simple. All you do is, here is the route that you want to protect. So if the users come to /users, if the user comes to /users, before I handle the request, here is the handling of the request. Before I handle the request, what should I do? I check whether they are authorized. So this is called the middleware function. So it's a middleware between the request and the request handler. So what this middleware is doing, what this is authenticated is doing, have a look at this. It goes to the authorization header. The user have to give me a token in the authorization header. I read it. If the ID is not there, I throw it at the user immediately. 403 forbidden, and I don't handle the request. That's it. I reply to them with 403 forbidden, and the story finished. Now, if the token has been added to the request in the authorization header, what do I do with this token? I read it, because remember, the token has three parts. The head, I don't care too much about the head. I care about the body. I take the body, I decode it. What I mean, I decode it, I convert it back to a user object. And then I store it in the user object, here. So this verify, this JSON verify, what this JSON verify is doing, it is making sure that the token has not been changed on the user side. It's also converting it back to the object, the original user object that was encoded in the token. And then what this middleware is doing, it takes this decoded token and assign it to this user object and attach it to the request. So why I do this is because in the route handler, I can access the user object and check some attribute that I care about. So in here, for example, I am checking, is the user role an admin? If they are an admin, I give them the list of users. If they are not an admin, I give them 403 forbidden. Yes? Is clear the idea? So it's very simple. So here is the route. In the route, what I do is I add this middleware, which is a function between the receiving of the request and the handling of the request. I pass the request through this middleware. This middleware extracts the token. It validates it. If the token is valid, it will allow me to handle the request. If the token is invalid, I return 403 forbidden. If the token is valid, the story is not finished yet. I need to check whether the user has the right role. In this case, the role expected is admin. If the user is an admin, I will handle the request. Otherwise, I'll give them 403 forbidden. So this is how I handle the security on the Node.js on the server side. Now, on the client side, on the Vue.js side, I also handle it in the router. I handle the security in the router. What I have in the router, I have this very useful function associated with the router. It's basically an event. Before allowing the user to go to a particular route, I check whether they have the right credentials, whether they have the right roles to access that route. If they are authorized, I let them go to the route they requested. Otherwise, I reject. I don't allow them. I keep them where they are, or I take them back to a login screen. Here is the demo app, by the way. So in here, let me just log out. And by the way, you can log in either using the local authentication, the local database, or you can log in using Google Sign-in. Let me just log in locally using my username and password. Once I log in, you can see here I have access to the users list. I can get to the users list. Now, if I try to access something called contacts, I get this error message here. You need to be authenticated using Google to access /contacts. So what I do, this logic, where I put this logic with the router. So the way we implement this, we implement it in the router. Here is my router. So in the router, I have this event for each. Before I allow the user to go to any URL, I check. If the URL requires admin, I check if the user is administrator. If yes, I allow them to go there. Otherwise, I will keep them where they are. I don't allow them to go anywhere. I stay where I am in the route that they are at. Some routes are not secure, anybody can access them. In such case, I will just allow the user to go to the route requested. So one way of doing one way of doing authorization on the client side using Vue.js is using what is known as the route guards. It's like putting a guard in front of your routes. Before you allow the user to visit any route, you check whether they have the right authorization to do so. Most likely you will be checking their role, the role of the user as part of the attributes of the token that was received after authentication. So here, it's very similar programming model, but you have to do it on both the server side and the client side, because the client could be compromised and somebody managed to undo or bypass the security on the client side. They will be faced with the authorization on the server side as well. So you have to do it in both, the server side and on the client side. You have to check the authorization before you allow the user to go and do what they asked for. Okay, so you already played with this. I'm just kind of summarizing the basic idea. So you can either have what is known as a global guard. This will be evaluated for each and every route. Whenever the user tries to visit another route in the client, they will have to go through this guard. And this guard will check their role. If they are allowed, it will allow them to go there. Otherwise, it will keep them where they are, or it will route them to the login page. It's up to you as a developer what the user experience you want to provide to your users. Now, another way of doing it is you can have a guard per route. Instead of having a global guard, for me, I prefer to have the global guard. I put all my logic there. But if you wish, you can have a guard per route. And to do that, you just have a function, and you associate this function with a property called before enter. Sorry, an event before enter, which means before the user is allowed to go to this route, I will take them through this check-in function. If they have the right role, if they are authenticated and if they are authorized, I will let them go where they asked to go. Otherwise, in this case, I redirect them to the login page. First of all, the delegated authentication. The idea is you don't need to manage authentication yourself in your application. You outsource it, you delegate it to some other provider, such as in our example, the example I'm giving here is Google. So here, instead of authenticating using my username and password in this application, I will authenticate, and the application will know me through my Google account. So it is beneficial for both the users and the developers. For the users, they don't need to remember so many passwords and create so many accounts. They can create one account with one of the providers like Google or Facebook or Twitter or other social networks, and they can use it to access many other websites. And for developers, they don't need to implement, every time they build an application, they have to implement authentication. They just delegate it. So here is how it works. So I'll click here, sign in using Google. So what it will ask me, this is now I am outside my application. This is not my code. This is Google's place. When you put your password here, I will not see it. My application will not see it. You are now dealing with Google authentication. I'm sure you have seen this in many places. So in here, I select the account I want to access, and I type in my username and password because I already authorized it. It's saying to me, it's supposed to ask me for consent, but I already consented before. It's asked me, do you want to allow this application called Hero App to access your account? And in this case, to also access my contacts, I said yes. So basically what I am doing here as a user, after I authenticate with Google, Google is asking me to give the consent, to give the authorization for this application to access my account and to access other data that I have with Google. In this case, I authorize this application to access two things. I authorize this application to access my account details, and I authorize it to access my contacts, my list of contacts. And you can see here, these details are coming from Google, the name and the username. and the email and a lot of other information. And these contacts are coming also from Google Contacts. They are not managed in my database. And here I can also add, I can delete contacts. I can, for example, here I can delete this one. And it gets deleted from the Google Contacts that I have. So here I'm showing you here two aspects of security very important for modern applications. Is this delegated authentication, which means I will outsource the authentication to another provider. I don't deal with it anymore. And there is also what I'm showing you here, another aspect is delegated authorization. Me as a user, I give you the authority or I give you the authorization to access some aspects or some data about, that Google is managing for me. And to really understand this in an intuitive way is the check-in experience we have in hotels. So what happens is when you go to a hotel, you go to the reception, and the reception here acts as the authorization server. So it asks you to prove who you are. That's the authentication part. It asks you typically for passport or for driver license or some ID. Why they are asking you all of this? To establish who you are and to provide them evidence who you are, who you claim to be. Okay? Once they prove that they know who you are, they will check the system. They say, yes, you have a booking with us from this date to this date. And then once you are authenticated, they hand over to you an access token. They hand over to you a card to allow you access to some part of the hotel. You cannot go everywhere. Okay, you have to go to particular parts. And then how they delegate to you, not full access, they delegate to you very controlled access. They will tell you your room 210. And they give you this token. You go to your room and basically use that token to request access. And you present your token to the door, and the door will be open for you. So that same analogy, we are doing it for web applications. So for delegated authentication, the standard for doing this is called OpenID Connect. And the standard for doing delegated authorization, it's called OAuth 2. And this is really the security mechanisms that are driving the modern web applications. We will encounter this as users, we encounter this experience, and also as developers, it's a must. It's not now kind of an optional thing to be aware of. If you want to use any API to access services, like through major service providers such as Google or Twitter or other business applications, you will need to be familiar with this. Because this is the way, moving forward, this is the way authentication and authorization is managed. So this is just to give you a glimpse of these two standards. And inshallah, next time I will explain them through much more details through the examples and coding examples. Okay, thank you very much, and see you next time.